Okay, hello. So in this video, we're going to be looking at finding stationary points. We're going to be doing this by differentiation. Now, before we start, we should just remember how we differentiate, and that when we differentiate, you find the gradient of a curve. So if we can remember the rule we've learned already, there's another video on that if you'd like to go and see it, if you're not sure about it. Basically, when you have y equals some power of x, you take the power when you differentiate and you multiply by the power, and then you take 1 from the power. So you just take whatever the power of x is, you take the power and you multiply by the power and you take 1 from the power to differentiate. Now, before we find a stationary point, we just need to discuss what a stationary point is, and by definition the stationary point is a point when the gradient is flat. That means when dy by dx equals 0. Now there's two kinds of stationary points. One's called turning points and one's called points of inflection. Now turning points, you can see here, when we turn, the curve turns right round. So it's going down and then it goes up, and then it goes up, and then it goes down. So this one's called a local minimum or minimum, because you can see that the curve reaches a minimum and then turns and goes up again. And here we have a maximum because the curve goes up until it reaches the maximum and then it falls down again. Now in a point of inflection, we have a change in the sign of the curvature of the curve. So here we can see it's curved that way, and then it changes, and then it curves that way. So it doesn't turn right down, it's just the curve changes direction. Okay, so to find the stationary point, what we do is we set our gradient, our dy by dx, equal to 0. And then we solve this basically to give us some x coordinates. We then go back and get our y coordinates. Okay, so here's a question. If you're feeling confident, off you go on your own. Pause the video and then come back to the next slide when you're ready. If you're not feeling so confident, you can do it with me. So we start off by looking at our curve. So our curve has more than one term in it, so we just go term by term, trying to stay steady, make sure we don't make any mistakes. So we start with x cubed. So x cubed, power is 3, so we multiply by our 3. Oops, there we go. And then we take 1 from our 3 to give us 2. We keep the sign the same there and there. And then this one we multiply by our 2. And when we multiply our 6 by our 2, that's going to give us 12. And then we take 1 from the 2 to give us 1, and x to the power of 1 is just the same as x. And then we have 9x. So this is the same as 9x to the power of 1. So we multiply by 1. So 9 times 1 would just give us 9. And then 1 take away 1 will give us 0. And x to the power of 0 is the same as 1. So that's 9 times 1, which just gives us 9. And then when we have a constant and we differentiate a constant, we get 0, because when we differentiate, we're looking at the gradient. And the gradient of a constant, so the gradient of a line 3, is flat. And so the gradient equals 0. So now we set that equal to 0 once we've differentiated. You can write that in 2 lines if you want. So now we say we look at this and we want to make our life as easy as possible. So if you look here, if there's anything you can factorize out, you want to do it now. So we look at this and we can see there's a factor of 3 in each term. So we take out that factor of 3, leaving us with x squared minus 4x plus 3. Now we're going to factorize this into 2 brackets. Now if you're not sure about how to do that, again, there's a video you can go back and have a little look at. But basically you look at this number here and you think of what 2 numbers multiply together to give you 3. So it's either 3 or 3 and 1, or minus 3 and minus 1. And then you look at the next number, this middle number, and you say which ones add to give us minus 4. So that would be the minus 3 and the minus 1. So now we want to solve this. Now we're trying to get this to equal 0. So what we do is we look at each bracket. We look at this bracket and we say, when would that give us 0? Well, obviously it gives us 0 when x equals 3, because 3 take away 3 would give us 0. And then we look at this bracket and say, well, when would that bracket give me 0? So we would get 0 from this bracket when x equals 1, because 1 take away 1 would equal 0. So we've now got our x coordinates. We've got 2 stationary points, one at x equals 3 and one at x equals 1. But we must remember, excuse me, we have to find the y coordinate. So we do this by putting our x coordinates back into our original equation of our curve. So we're going to put them back in here. So we're going to do x equals 1 first. It doesn't matter which way round. So we can see that 1 cubed minus 6 times 1 squared plus 9 times 1 plus 1 equals 5. That's the answer on that one. And at x equals 3, slightly harder, so we get 3 cubed minus 6 times 3 squared plus 9 times 3 plus 1 gives us 1. Please pause and check and see if I've got it wrong. All right, hopefully. You can always let me know if it's wrong. And so then we have that the coordinates of the stationary points are 1, 5 and 3, 1. And I'd like to write it out. I know in exams it's everybody's pressured, but if it's right, it lets your teacher or your examiner just say, oh yes, that's nice, that's right. And then we don't have to trawl through everything else. Of course they will, but to see that you've done the right thing. Anyway, hopefully that is helpful. In our next video, we'll be looking at finding the nature of our stationary points. So we know our curve stationary at this point, but we don't know whether we've got a maximum, a minimum, or a point of inflection. So that's the next thing we have to look at. Okay, thank you.